This is the screencast for section 3.9, example 6. We're going to find the domain of a derivative. Basically, in a domain of a derivative, you're going to exclude all the restrictions of the original function f and any restrictions you find new in f prime. And that will get you the domain of f prime. So, looking at our example here, if f of x equals the natural log of x minus 3, so that's this graph up here, I'm going to call that f of x. We're going to find f prime of x and state the domain of f prime of x. Well, first of all, the domain of f is going to be, well, we can't take the log of negatives or 0, so it's going to have to be anything greater than 3, so 3 to infinity, which you can see from the graph here. The derivative of the log base a of u is 1 over u times the natural log of a, which in this case is e, times the derivative of u, which is 1. So in short, this will be 1 over x minus 3. Not too complicated. So it looks like the domain of f prime can be anything but 3. However, we see that there was no function to the left of 3 in the original, so we have to cross that piece out, and really the domain of f prime, or the derivative, is only going to be from 3 to infinity. So finding the derivative didn't add any new restrictions for us. We just had to carry on the old ones. The now try problem, number 37, also asks us to find f prime and state the domain of f prime. Well, let's see. The domain of f, in this case, is going to be, again, can't take the derivative of negatives, can't take the log of negatives or 0, so that's going to be anything greater than negative 2. So the derivative is 1 over x plus 2. So it looks like f prime's domain is all real numbers except for negative 2, but we have to follow the restrictions from f. The domain of f prime is, again, negative 2 to infinity. And I graphed both of those here on the same curve by telling my calculator in y1 the original function, but in y2 I told the calculator to take the derivative, so it got the derivative right, because it's not going to make up the equation and then graph that. It's going to find the derivative of every point existing on f, so that can give you a clue also to what your domain of f prime would be if you graph it using the calculator's function.